speaker I'm going to introduce is Ashok Vaseashta. I'm sorry, I'm sure I've got that wrong. He is a professor in several different universities around Europe. He is a professor at Riga Technical University in Latvia. He is a professor of nanotechnology. Now that's another fabulous job title. Professor of nanotechnology at the Academy of Sciences in Chisinau in Moldova. He is the director of research at the International Clean Water Institute. And he's going to be talking to us about water, or about transdisciplinarity in mapping the future of water. Ashok, please make your way to the podium and coexist with that incredible planet next to you.
Thank you very much. I'm sure all of us drink water. So,
can we get the slides on the screen, please?
I was told one of them works, so as long as you can hear me. And I also know there is some resonance, so I'll try to be slow. But there are lots of pictures just to make sure that we have communication. All right, now I can see the screen. As the chairman mentioned, I have a few affiliations with universities across the Europe and also in US. International Clean Water Institute it was actually started by funding from Department of Defense and also from NATO. That was in 2009. And now I have converted into a nonprofit consulting organization providing feedback to the government as to what we can do from water. And as you see, there are different operational platforms going from distance learning, cyber defense, and I'll explain to you what that, how that fits into the overall picture. Defense technologies with the overall objective of safety, security, and sustainability. There were 5 countries on your left which initially started this organization. Now there are 7, and obviously increasing. So this is a picture which I had displayed a long time ago, way back in mid-1980s. That time I was working on solar cells, and obviously that produces energy. And in that context, to see how it offsets the carbon footprint, I took a survey asking people what are the top 10 global challenges. And you see on your left, going from energy, water was there at that point. And it's interesting that all of these are still today relevant, which later were converted into, of course, we have created groups. They continue to advise us on the global priorities in terms of vertical and horizontal.
Put this because there's a problem with the sound of this thing.
Oh, I see. Okay.
So better.
It's interesting that I have Mars right besides me, and we are sending people to Mars to see if there is water. But there is some background noise coming from there, so I guess, in any event, we continue to organize different groups which continue to give us priorities as the horizontal and vertical priorities. And there is a component of microplastics, which I'm going to introduce a little bit later. But as you know, all of that was converted into Millennium Development Goals. There were 15. Now there are 17 Sustainable Development Goals. And if you see CD, this Jose contributed to that. So obviously, congratulations to Jose for, continuing to contribute to this effect. So here is a brief outline. I know that my time is limited. I'm not going to go through all the points, but this is essentially by way of pictures, by way of some examples. This is what I plan to present, starting with why water. Water is a very unique molecule. And the interesting part is that physicists, chemists, engineers, they cannot agree to one definition of water. If you ask them, they will give you different definitions of water. As you know that life without water is impossible. Of course, all of us know that. Water is worshipped. I had seen my mother worship water when I was a little child. I did not know at that point what that meant, but now I know what she used to do at that point. Water has many fascinating characteristics, and I'm going to point out only two. One is the density. As the temperature decreases, water contracts, but below 4 degrees Celsius, it expands. And what that does is, that's the reason once it freezes, water floats. And it is for that reason the fish continue to live. It's because of that characteristics. So if that was not the case, obviously we would not have fish to eat. It has strong solvent characteristics. And somebody asked me yesterday if I'm transhumanist. In a way I am, because I work on water. I try to produce clean water. And if we have clean water, we will have longer life because of the fact we have less contaminants in our body. So as I mentioned, these are some of the characteristics of water. Without water, I don't think we can even blink our eyes. I cannot move my arm if I did not have water in my body. As you see, our muscles, brain cells, blood, bones, all of them have tremendous amount of water. So as mentioned, you cannot even blink your eye if we do not have water in our body because it serves as a lubricant. Of course, saliva and so many other fascinating characteristics of water. It's also for metabolism, detox agent, and so forth. So there is a great water-human body interaction. And the situational awareness is that water, although it's most abundant, we have it globally, but nonetheless, it's not clean. So obviously, it's a major challenge globally from the sustainability standpoint. And that's the reason it's very important that we continue to work on clean water. So I'm going to take you through some of the pictures, but there are 2 or 3 which I'm going to sort of give you brief explanation about. Talking about water scarcity, these are some of the statistics which I'm sure you know. Close to about 2 billion people worldwide do not have access to clean drinking water. Some estimates 1 in 4, 1 in 5, so forth. Over 50% of developing world without clean water or without actually toilet facilities, it impacts female more than men. So as you see, without toilets, girl typically would drop out of school if their facilities or the school does not have clean water. 64 to 65% of families depend on females to make sure that we have clean water. So obviously, as I mentioned, there is a gender inequality, not that I focus on that, but because of the fact females are care providers, it impacts them more than men. 76% of people live in water-stressed areas. And here's the interesting fact, that 2/3 of the population live in areas where 80% of rainfall occurs during 20% of the year. So either it's too dry or too wet. So obviously that creates water scarcity. So this is the graph which you see on the screen. The gray is the water stress, and the blue is the scarcity, but nonetheless, both of them are increasing globally. All right, so as I mentioned, these are pictures. I have tons and tons of those, and I'm sure you've seen them, but there are 3 pictures I'm going to give you a very brief explanation. Here is the first one, because of the fact I have association with a university in Armenia. They were our initial part of the NATO project. This is area called Kapan. Beautiful area to look at, but if you see the water, because of the fact Russians had dug lots of metal mines, and this is the water which you see for irrigation and also comes from water tap, and the mayor will tell you the water is clean. Obviously, that's not clean. This is an area next, very close to my home in West Virginia. This is Charleston Kanawha River, and lots of companies are there. They would discharge raw material into the river, and that's the intake for water municipality, for the water which comes to people's home. And there are a large number of people, students, kids, those who have autism. And if you publish this, their lawyers will come after you because they don't want you to publish all this information. But you see that all the time. This is area at the border of Uzbekistan and Kazakhstan called Aral Sea. We've been monitoring this since middle 1980s. As you see, 1985, 1992, 2000, the whole lake became one because of the fact it was decreasing. And number of people, thousands of people around that lake are very sick because of the fact Russians dumped lots of chemicals. So there's a book which I've listed. Perhaps you can pick up that book and then you will see the origin of that lake. And that's not the only one. There are so many other lakes in Lithuania, in Latvia. There are lakes such as that. So obviously these types of contaminated water produces disease. Nearly one out of every 5 deaths under age of 5 is because of water. And there are lots of other statistics indicating that because of the waterborne disease, we suffer so much financially, economically, and also health-wise. Plastic. I know plastic is one of the biggest inventions. As you see, global production of plastic continues to increase, as is given in this slide. But nonetheless, this is the consequence, and I'm sure lots of you have seen these types of plastic. The top right comes from California, and as mentioned, you will see that in the ocean, and there are lots of animals, those who suffer because of the fact that lots of people discard plastic in the environment. There's hardly any plastic waste management. There is on paper, but nonetheless, it's not commonly exercised. As a result, large number of that ends up in the landfill. Although the graph also shows that people compost and burn, but that percentage is very, very small. So as a result, this goes into the water over a period of time. It degrades into micro and nanoplastics, as is shown, different types of beads and so forth. And also, I'm sure you know, your toothpaste contains microplastic because of the fact it has plastic beads. They also end up in water. And our filtration system are not capable of filtering those microplastics out. So all of that ends up in our food supply chain. As a result, there are toxicity, which obviously is creating major impact worldwide. And here's the interesting part, that there is very limited human data. We are using nanomaterial-based concept to see if we can help understand microplastic or nanoplastic, their impact on human health. On the right, there is a model which I just published a few days ago. This is the microplastic which floats in the top of the water. And over a period of time, it becomes almost like a gooey. It has a hydrophobic characteristics, and it attracts bacteria. As a matter of fact, if you have plastic, the water is sitting on it, you will see that it'll become sort of sticky because of the fact it's attracting bacteria. So that's what that model talks about. So we're looking into toxicokinetics of microplastics. The interesting fact is that microplastic over a period of time mimics estrogen. Water itself has lots of estrogen because of the fact the return pharmaceutical in water have lots of antibiotics and so forth. They have estrogen, and microplastic also mimics estrogen. So as a result, our lakes have tremendous amount of estrogen that in California and Nevada, 30 to 40% of fish have dual gender because of the presence of estrogen. So obviously, this is a global challenge which we continue to monitor. So in the book which I had published some time ago, we had listed lots of contaminant. We took one more survey, and on the top side you see clean water. 100% of the people now agree that water is a major problem. So this is sort of background as to why I wanted to talk about future of water, how we can find ways to get clean water so that as transhumanists, we find clean water to increase our lifespan. Interesting part is there is a definition of water quality, which refers to a chemical, physical, biological characteristics of water. But the important part is that if you go from country A to country B, the definitions are different. All of us have pretty much same body composition, body constitution. As a result, I'm trying to introduce a universal water quality index. That means all of us have same good quality of water and not dependent on what a specific country has. Obviously, there are different types of potable and drinking water, which are used for different industries, etc. But at least from drinking standpoint, as I mentioned, I'm trying to introduce a term, which is the Universal Water Quality Index. So looking at the water, if you look at this picture, although our globe consists of lots of water, but the clean water is either in lakes, in rivers, and the third largest composition of water is in atmosphere. And that's where we're trying to tap into to see if we can capture that water. I do not have to be physically connected to the grid. I can have atmospheric water harvesting, and I can produce water wherever I want. And this is something which we are looking into. So these are some of the topics. I cannot discuss all of them, but I'll discuss at least some of them. Atmospheric water harvesting is something which we are looking into, trying to produce different ways where off the grid we can produce clean water. Diplomacy in transboundary water management. Transboundaries, I'll show you a couple of pictures. There are aquifers at the transboundary. Lots of places have them. But nonetheless, there has to be diplomacy, because if the neighboring countries are at war, obviously there is a problem. So that's something which needs to be worked on. Use of technology to sense, detect, mitigate contaminants. Region-specific contamination remediation strategy. What that means is, I know Spain has very clean water, so the contamination remediation strategy has to be different than what's in Africa or elsewhere. So that's what also we are working on. New and innovative ways to use, reuse, recycle, including zero liquid discharge technology. Use of decision support tools, technology convergence, cyber-physical systems, use of artificial intelligence, bio-friendly compounds for water filtration membranes, as I mentioned, universal water quality, and transdisciplinarity. So these are some of the approaches. Again, time is limited. I cannot go into all of that, but some of them I'm going to discuss. One is the atmospheric water harvesting. So by using solar panels, using metal organic frameworks, using nanotechnology, we are looking into different platforms which simply captures atmospheric water And this would be one of the future sources where we can have water. UAE is investing into this technology literally in millions because of the fact they need clean water. And of course, as you see this Aqua Sciences truck, they will send this truck, and these have the capability of capturing lots of atmospheric water. Transboundary water, as I mentioned, that there are 263 international basins, but nonetheless, as you see in this slide, Jordan, Syria, Israel, a river that always in a conflict, Nile, Ethiopia, Sudan, Egypt, there's lots of transboundary water, but nonetheless, there's again conflict. India, Pakistan is pretty much the same thing. Every summer, whenever there is water shortage, the river flows backwards. As a result, the war breaks out every single year, and so forth. And this news article, I was on my way from Moscow to somewhere in Europe, I believe Amsterdam, and I was looking into the newspaper, and it talked about war in Libya. It stopped, not because Gaddafi died, it's because of the fact they did not have clean water. So obviously, like I said, that has lots of implications. I work on nanomaterials, and that is one way to use new technology. What this slide simply shows is nanomaterials are particles of extremely small dimension. Their dimensions is close to fundamental physical quantities. And what that means is I could create a material of my own choosing. And that's the reason nanomaterials are important, because you can create something which is of your own liking and choosing. Also, they have very large surface area compared to their diameter. And that means they have a lot more surface activation energy. As a result, they are good filtration materials. And Army, they have asked us to produce what's written on the left, such as wearable kidneys, water desalination, water purification plants, wearable anti-dehydration systems, all based on nanomaterial. They are looking into lots and lots of application, and some of them I have listed in this particular slide. We are looking into advanced sciences convergence, what occurs at the multiple field, and see how we can look at that intersection and solve some of the problems looking at advanced sciences convergence. Decision support tools, as I had mentioned, that we, any entity such as government or private entity, they would give us a problem to work at. We look at different decision support tools. Okay, just about done. Different decision support tools to see if we could find solutions for them. This is one classical example where we have 3 different tools, TechFarm, Adams, and Nests, to provide data analytics. We look at different technology convergence as to how we can map. We have a project on technology accelerator, meaning thereby people, those who have different technology, we try to bring them together and create partnerships for technology acceleration. This is one classical example, which is the Materials Genome Project. What that means is using nanomaterials, we can then provide technology acceleration. We also use cyber physical system. This is for Internet of Things. This is a course which I'm teaching also on the cyber physical system. This is simply for monitoring, sensing, detection, etc. Smart and connected communities is part of Internet of Things. As I mentioned, it has different capabilities which obviously can be tapped into. Again, we could use different types of algorithms. For the Universal Water Quality Index, we are using AI to actually calculate that index for us and provide us a clear concept for the Universal Water Quality Index, and we are using AI for that. So essentially, it's all convergence of technology, which would provide us information as to what path we must choose going forward out of technology. Just as this is the very last slide that, as I mentioned, because of the fact microplastics pose a lot of problem, the recommendation is to use bioplastics and biopolymers. These are based on biomaterials. These are degradable. So obviously that would help the problem of microplastics. Anyway, I'll pass this one. This simply indicates that all what I have discussed about science and technology, we are looking into societal application, and that's the part of transdisciplinarity in water research. So with that, I close as a take-home message that water is an exclusive resource which we need to carefully manage, use, reuse, and recycle, implement Universal Water Quality Index, research to mitigate emerging contaminants in water, persistent monitoring of contaminants in water, reduce micro-nanoplastic, reduction in return pharmaceuticals, advanced technology to ensure water quality, alternate ways to harvest water, and so forth. With that, I thank the chairperson, thank all of you, thank Jose for organizing this wonderful conference.
Incredible. One quick question. If you're taking water out of the atmosphere in large quantities, do you risk doing damage to the weather or the climate?
I'm sorry?
It's difficult to hear back here, isn't it? If we're taking water out of the atmosphere, as you have proposed, in large scale, does that risk damaging the weather or the climate?
As I mentioned, it's such a large resource. It's almost equivalent to saying if we take water from a lake, it's a reserve. So because of the fact, technically it's the second largest reserve. So I do not think that if we start taking, it would damage the environmental reservoir of water.
And you mentioned a lot of hope for nanotechnology. Nanotechnology might do desalination of salt water into fresh water. Nanotechnology might be a good solution to all these plastics we have put into the oceans. How far away is that? Is that still 20 years away as a dream, or might this be here sooner than that?
Well, that's a wonderful question, by the way. As far as the microplastics is concerned, we have made, based on nanomaterials, we make nanofiber using electrospinning technique, which is a very simple way of making plastic, biodegradable plastic fiber. We can add into those different types of compounds which capture not only pharmaceutical, but large hydrocarbons. Because plastic is a large hydrocarbon, so we can capture microplastics, we can capture nanoplastic, we can also capture different types of pharmaceutical. However, large-scale production is still in question because of the fact that we have to produce that on a large scale. But proof of concept, laboratory experimentation, that has been done and very well proved, so we can capture all of that.
So probably in Transvision 2022, we should have a whole panel on progress with nanotechnology, because the possibilities are incredible and we need to understand the opportunities and any risks. Thank you so much, Ashok.
you.